Dear students, today we are going to start with another titration, that is iodometric titration. The aim of the experiment is to determine the percentage of available chlorine in a given sample of bleaching powder, and another name for this experiment is iodometric titration. The reagents which are required for performing the titration are bleaching powder, 10% Ki solution, glacial acetic acid, start solution as indicator, sodium thiosulfate as which is a reducing agent, potassium dichromate oxidizing agent. The starch which we are using should be a freshly prepared solution. Now, what are iodine titrations? They are basically redox titrations where the iodine is directly or indirectly used as an oxidizing agent, and the iodine titrations, they are of two types. They are iodometry and iodemetry. Iodometry titrations, they involve the direct titration of iodine, which is liberated by reaction with the analyte. Iodometry, it involves direct titration using iodine as a titrant. Starch, the indicator which we are using, is a natural polymer, which is a carbohydrate and also known as amylum. It consists large number of glucose, which are joined together by glycosidic bonds. The starch consists of two moieties. The two moieties are amylose and amylopectin. Amylose is a linear chain structure, whereas amylopectin is a branch chain structure. Amylose is water soluble, whereas amylopectin is water insoluble. Amylose, the linear polysaccharide, they are linked by alpha 1,4 glycosidic linkages between the glucose residues, and amylopectin, they are branched, linked by alpha 1,6 linkages between glucose residues and also by alpha 1,4 linkages. So amylose linear chain, amylopectin is a branch chain structure. Let us start with the theory. The bleaching powder, why we need to know the percentage of available chlorine in the bleaching powder. Basically, this bleaching powder is commonly used as a disinfectant. The chlorine which is present in the bleaching powder gets reduced with time. So we need to know the exact quantity of the bleaching powder which is required, so that we also want to know the amount of available chlorine which is present with the particular sample. The bleaching powder is made up of three constituents. The three constituents are calcium hypochlorite, basic calcium fluoride, and some free calcium hydroxide. The calcium hypochlorite is actually responsible for disinfection and bleaching action of the bleaching powder. So when the bleaching powder is used the bleaching powder is actually used for bleaching actions also, and it is used for bleaching cellulose, cotton and linen also. So now when we are using this bleaching powder with the acid, when we react this bleaching powder with the acid, this chlorine is liberated over there. Whatever the chlorine is liberated is known as available chlorine. So the number of grams of chlorine which is liberated from 100 grams of bleaching powder when it is treated with dilute acid is actually referred as the available chlorine. The continuous decomposition of bleaching powder during storage is its main drawback, and it also absorbs moisture from atmosphere and evolves chlorine. Due to this deterioration, a little bleaching powder comprises of less quantity of chlorine than estimated. Therefore, we need to analyze our bleaching powder sample. Now, as you can see, the bleaching powder, when it is reacting with any of the acids like HCl, sulfuric acid and acetic acid, it is releasing this chlorine. So this chlorine, which is liberated when it is going to react with potassium iodide, the iodine is liberated, which is actually equivalent to the amount of active chlorine. And afterwards, the same iodine is titrated against standard sodium thiosulfate solution. And when this iodine reacts with sodium thiosulfate, it forms sodium tetrathionate and sodium iodide. So the aqueous iodine solutions, normally which contains potassium iodide, um, the iodine and iodide, they together forms triiodide, and it keeps in equilibrium. So iodine plus iodide, they themselves converted into iodate, and the iodate is much more soluble than iodine, and and it is as iodate, the iodine is kept in the solution. So once it is converted into iodate, it is easy to solubilize, and it is easy to get the release of this iodine, which can be easily titrated against the hyposolution. So always remember, we always use excess of Ki when we are performing this titration, and this excess of Ki will lead into the formation of these iodate ions, and iodate is much more soluble, soluble than iodine. So once this iodine is released, sodium tetrathionate and sodium iodide is formed. The iodine is going to react with the starch, which is actually an indicator, and forms a charge transfer complex, which is an iodostarch complex, and is having a bluish black color. This formation of iodostarch complex shows that the iodine which was present in the solution is now reacted with the starch. So when we reach to the end point, at the moment we reach to the end point, the solution colors turn into colorless solution. That means the disappearance of this bluish black color is there, and due to that the solution turns colorless in nature. The two different sets of reactions are there. The another set of reaction is when the chromium ions are going to react with these iodide in the presence of the acid. The chromium changes its oxidation state from +6, it goes to +3, and the iodide is converted into iodine. So the redox reaction is taking place, and at the end point you are going to observe a characteristic green color. That characteristic green, leafy green color is because of the chromium ions which are present in the 3+ state. So the two types, the sets of the reaction are totally different. This sets of reaction when you are estimating the chlorine in the bleaching powder, and this sets of the reactions will take place when you are performing the standardization of your hyposolutions. So let us start. Let us begin with the titration, with the procedure part. But before that, again, two things always remember. Number one, we use excess Ki, and excess Ki is used so that iodine should be available. Number two, we prefer the iodine titrations need to be performed in the cold conditions. The reason behind that, iodine is volatile in nature. To prevent the volatilization of iodine, we keep the solution cold. Number two, the excess Ki also prevent the volatilization of iodine. So that is why also we use this excess of potassium iodide, so that this potassium iodide, the iodine plus iodides, they will convert themselves in terms of iodate, which is more soluble in comparison to iodine. Now, let us start with the first part, that is preparation of a standard potassium dichromate solution. So the weighed amount of potassium dichromate will be given to you. The same weighed amount you have to transfer into 250 ml standard flask. Dissolve the crystals with distilled water and make the solution up till 250 ml mark. Shake the solution so that you can get a uniform concentration. Afterwards, you need to calculate the normality of potassium dichromate. So put the weight, that is 1.25, multiplied by 4, divided by equivalent weight, that is 49.03. Calculate the values, calculate the formula, do the calculations. You will get the normality of potassium dichromate. Now proceed with the next part, that is standardization of hyposolution. So here you are going to pipette out 10 ml of this standard solution, that is K2Cr27. And in that K2Cr2 solution, you are going to add 3 ml of concentrated HCl and 5 ml of this 10% of Ki with the help of measuring cylinder. Both the solutions will be added with the help of measuring cylinder. And then you are going to add 1 test tube of water in this. As I told, why we are adding this distilled water? We want the solution, we want to carry out the titration in the cold conditions so that iodine should be available in the flask. It should not volatilize. Now, when everything is mixed over there, you can observe that still we have not added starch in it. So now you start the titration. Start the titration. The flask is containing potassium dichromate, concentrated HCl and Ki in it. The solution is dark brown in color. Titrate it till your solution turns into light brownish green in color. And you have to be very careful. If you will not, if you keep on performing the titration without even the adding of this starch indicator, you will land in the situation where you are going to get the leafy green color. So that means without indicator also we can reach to the end point. The reason why we are adding starch is to get a sharp end point. If we will not add, because this light brownish green color, then suddenly it changes into leafy green color, it is difficult to perceive at that moment. So once we are going to add this starch at the light brownish green color, again your solution will turn into dark in color. Then you add another few drops of sodium thiosulfate, and suddenly your solution will turn into leafy green color. So it is easy to perceive the color change at this point. And that is why we are telling that if without addition of starch also you can reach to the leafy green color. But why we are adding starch? So that there should be a significant change, color change should be observed easily. So once your solution turns into leafy green color, at that moment you have to stop the addition of hypo, note down the reading and repeat the titration for the concordant values. Now for the calculation of normality of hypo, you have to put the value, you have to put the normality of potassium dichromate multiplied by the volume of potassium dichromate, that is 10 ml, divided by the volume of hypo which you have obtained through the titration. Calculate it, you are going to get the normality of hypo solution. Moving ahead, you need to prepare a bleaching powder solution. So the weighed amount of bleaching powder will be given to you in the pestle mortar. In that pestle mortar, you have to add little amount of water, grind it well, and make a smooth paste of this bleaching powder. And make sure that there should be no granules. A smooth means very fine and smooth paste is required, because if you're not going to make a smooth paste, the granules will have chlorine in it, and the liberation of chlorine will not be a proper one. So that is why you need to grind, you need to crush all the granules which are present in the bleaching powder, as the bleaching powder is hygroscopic in nature. That is why it might be having some granules in it. So आप उन सारे granules को तोड़ के अच्छा सा fine paste तैयार करेंगे, so that the iodine and so that the chlorine should be released easily. Once the paste is converted into a smooth paste, you need to add distilled water in it and transfer it into 250 ml standard flask with the help of the funnel. Make sure that your pestle mortar doesn't contain any particle or any residual bleaching powder in it. You need to take each and every part of this bleaching powder, because it is going to be utilized for the calculations. So once your solution is prepared, once it is transferred into the standard flask, you will observe that the solution is trying to settle down. So the settled solution, the upper part is clear solution, and the solution which is at the base is quite turbid in nature. So the upper part, upper solution is a clear solution. The lower part is a turbid solution. And when you are using this solution in a titration, you need to take the turbidity along with the water. So that you need to shake your solution very well. If you are going to use this clear solution, you will get a very early endpoint. If you are going to use highly turbid solution, you are going to get a very late endpoint. So that is why if you will make the solution, if you swivel it, if you mix it properly, if you make the concentration even you are going to get the correct endpoint. Now, how to use this bleaching powder in the estimation of the chlorine? So now, whatever the bleaching powder solution you have prepared, you have to pip it out, 25 ml of this bleaching powder, and you release it into the conical flask. In this bleaching powder, you will add 10% of Ki and 5 ml of glacial acetic acid. The reactions which are actually taking place here are this. The chlorine which is present in the bleaching powder will be released over there. You have added Ki. So Ki will react with chlorine, forming potassium chloride, and the iodine is released over there. This iodine, when you will titrate it with sodium thiosulfate, will form sodium tetrathionate and sodium iodide. Now, once the sodium tetrathionate is formed over there, at that moment, your solution will turn into light yellowish color, or you can say straw yellow color. You have to stop the titration when your solution turned into lightish yellow in color. At that moment, you are supposed to add 1 ml of starch. अगर आपने light yellow color पे stop नहीं किया, तो directly you will land in a situation where solution will turn into colorless solution. So you have to be careful. You need this light yellow color, and so that at this light yellow color, when you will add starch, again your solution will turn into dark color. So once your solution turns into dark color, titrate it against hypo, and at the end point you are going to see that dark color is basically because the formation of charge transfer complex, that is the starch iodide complex, is formed over there. So that is why I'm telling that you are having a dark bluish color or dark bluish black color because of formation of a starch iodide complex. So once this complex is formed, afterwards again proceed with the titration. Your solution will turn into colorless. The moment your solution turned into colorless, stop the titration because now you have reached to the end point of the titration. So now the same procedure you have to repeat for another 2 times for the concordant value. How you are going to do the calculations for the estimation of the chlorine. So you have to note down the initial reading, then you note down the final reading, subtract V3 value from the V4, you are going to get the volume, that is V5. Now, whatever the volume you have obtained through the titration, you need to use it for further calculations. So we know that 1 ml of this hypo solution is going to use 0.03546 grams of chlorine is equal to this. So we need this volume 5. We will put this volume 5 and multiply it by the normality of hypo, which you have already calculated before. So take the value of 0.03546 into volume V5 multiplied by the normality of hypo. You are going to get the value Y, which is actually present in 25 ml. You need not to divide it. This much amount is present in 25 ml. So now therefore the weight of chlorine in 250 ml you need to calculate. So take this value Y multiplied by 10 and then divide it by 100 into the value Y into 10 कर लीजिए, Y into 10 करिए, you will get the value B. Then you need to calculate the percentage of chlorine. You will have to, this 100 multiplied by B will give you the weight of will give you the percentage of chlorine to you. So that is how you are able to get the percentage of chlorine in the given bleaching powder solution. So finally, you are going to report the result, that is how the percentage of what is the percentage of available chlorine is present in the given sample of bleaching powder. Now, two, three things which I want to focus here. You might have a question in your mind that why every time we are adding this starch near the end point, why not we are adding this starch in the beginning of the titration? ऐसा क्यों हो रहा है? Up till now, whatever indicators we have used, we have added in the beginning of the titration only. But here we are waiting till the solutions were converting into light in color, and at that moment we were adding starch. So the addition of this starch, the reason behind adding of this starch near the end point, the two reasons are there. Number one, in the beginning, the concentration of iodine is quite high. So when you will add this indicator at the beginning, you are going to get a diffused endpoint, because whatever the iodine is there, it is going to sit inside layers of the starch, and basically it is actually fixed with the amylopectin, and the phenomena of absorption will be there. So once the things are absorbed, it is very difficult to take back those things. So now what we are doing, basically, we are reducing the concentration of that iodine through the titration and making the solution light in color. Light in color means that the concentration of iodine is reduced over there. So when at the reduced concentration you are adding that starch, at that moment the phenomena of absorption will be there, and iodine is going to sit at the surface of the starch. So when the iodine is sitting at the surface of the starch, it is very easy to take out or to release that iodine from the surface. That is why we are adding this starch near the end point. Now another reason, the starch shows, or the starch is having a tendency of decomposition, or it gets hydrolyzed in the acidic medium. So at that moment, if it is hydrolyzed, it is not going to be able to perform its role as an indicator. So now what will happen when you will reduce the concentration of iodine? By that time, the acidic medium is also reduced. The concentration of acid is also reduced, because the reactions which are carrying out over there are in a acidic medium only. They are above 8, you can say. So that moment when you are going to add a starch, it is not at all going to be harmed over there, and it will easily perform its duty as an indicator. Again, I will repeat two reasons. Number one, if in the beginning if you will add a starch, the starch will go and sit inside the layer. It is difficult to take out that starch, and due to that you are going to get a very early endpoint. So if you will reduce the concentration of iodine, and at that moment when you will add the starch, it will sit at the surface of the starch, and it is easy to take back that iodine from the starch surface. The another reason, the starch goes or shows decomposition in the acidic medium. So due to that, and the acidic medium is required to promote the reaction between the oxidizing agents and the iodide. So first we will carry out the reaction. We make the concentration, we make the concentration lower, so that the starch will also be able to perform its duty, and also we are able to get the iodine back from the surface. So this is how, that is why we are using this starch near the end point. Another thing, in the beginning, the percentage of chlorine which we are calculating, but during the reaction, when we are performing this iodometric titration, we have replaced the chlorine with iodine. So again, you should, if you remember, the chlorine, iodine, bromine, अगर आप तीनों को देखें, तो iodine is larger than chlorine. Iodine is larger than chlorine, and all of them, they are having a volatile nature. But in comparison to iodine, chlorine is much more volatile in nature. And then proceeding with the that chlorine in the titration will lead into a wrong results. That is why we have replaced the chlorine and we have performed iodometric titration. Iodine is also volatile in nature, but in comparison to chlorine, it is less volatile. And as the size is bigger in comparison to chlorine, it will take more time to volatilize. So that is why we have replaced the chlorine with the iodine. So this is all the explanation of the experiment, the theory part, and two things more which I want to focus. The factors which actually affects the iodometric titration. Number one is the hydrogen ion concentration. The hydrogen ion concentration, it increases the oxidizing power of the oxidizing agents. Hence, the hydrogen ion concentration is directly proportional to the oxidizing power of the oxidant. So, it increases the iodine activity. So, number one factor. Number two, the pH of the sample solution. Even though we have not maintained any pH over there, but always remember the pH of the solution is inversely proportional to the oxidizing power of the oxidant. The increase in the pH decreases the iodine solution activity, that is oxidizing power. So these two factors which affects the iodometric titration. And the precaution part, the titration should be carried out as quickly as possible because iodine is volatile. And to prevent this iodine, we we are using cold conditions, and also we are putting excess iodide over there. Number two, always prepare or always use a freshly prepared start solution because it shows hydrolysis or the decomposition. Next, the for adding any kind of acids in the reaction, acids and Ki solution, we need to use measuring cylinders. Thank you for this explanation, and the remaining slides are of calculation parts which you can go through when you are going to see the demonstration video. Thank you all.